Welcome, 11.5 video. Let's get started. We're talking about volume still. We're introducing volume of a pyramid and a cone today. So these are actually very similar to the prism and the cylinder. Really the only main difference that we have here is actually this piece right here, 1/3. Okay? We talked in class about the base of a prism. We have to have two of them. They're parallel to each other. In a pyramid and a cone, we only have one base. They're really easy to find because it would be what it could sit on, and it would look like a pyramid. So usually these aren't the tricky part to find, but we still do the area of the base times the height, and that has to be perpendicular because now we're talking about the distance, from the base to the top, perpendicular. And we take 1/3 of that. If you were to take the same size base of a pyramid with the same height for a pyramid versus a prism, you're going to notice that it's going to hold 1/3 the amount of space. So let's go ahead and write all of that down, and let's go ahead and write all of this one down. And this is the same thing, same as the cylinder, except for we're doing 1/3. Okay. So let's jump into these problems. Again, make sure that you write all of that down right there, and let's get going. Here we go. First problem I wanted to look at, I believe, was right here. We'll just pause that for a second. Okay, so the entrance to the Louvre Museum in Paris, France, which I've been to. If you haven't, it's spectacular. It's a square pyramid base, so our base is a square with a height of 21.64. What's the approximate volume? Okay, first thing we always want to do is we want to go ahead and try and see if we can draw in our height. So there's the height right there. So you can draw this as a pyramid. You don't have to draw the Louvre itself. And this measure right here is going to be the height of 21.64. Okay, so our volume equals 1/3 the area of the base times how tall it is. Okay, so and that's the distance. The height is the distance from the base piece to where all the triangular pieces meet. Okay, so we can go ahead and plug this in pretty easily. We know that our height, we know already, is 21.64, and the base is going to be a little different. So we have a square base. It tells me it's a square. So to find big B, I'm going to do off to the side, is 35.4, and that's squared, because if you guys remember, to find the area of a square, it's just side squared. Okay, so I just need to grab my calculator because I forgot it. So I'm going to go ahead and disappear in 1 second. Watch this. I'm going to hold a calculator here. And 1, 2, 3, 4. See? I got my calculator now. So let's go ahead and calculate this out. So 35.4 times 35.4. Mess that up. 35.4 squared. Okay, and we come up with that answer right there. 35.4 squared, 1,253.6. So the area of the base, 1,253.16. So we can use that guy in our equation now. That's a period right there. And then divide that by 3. I'm going to do the rest of that in the calculator here. My head's kind of itchy all of a sudden, I don't know why. So multiply that by 21.64 and divide by 3. And we should come up with volume equals 9,039 point, and it says round anywhere. What's the approximate volume? We'll just leave it as 0.5. And this is going to be in cubic meters. Yeah. All right. let's go ahead and move on to our next question. And here we go. Bada bing, bada boom. And here we are. Okay, so this one's slightly different. Notice I don't have a height here, okay? But we can get one, all right? I can actually just draw in a right triangle here, okay? So there's kind of this like right triangle embedded into the pyramid, and we have the height here, 25 here. You might be asking yourself, Mr. Smith, what the heck is on your face? Ha! It's me, guys, don't worry. So if you were worried, don't be worried, it's just me. So anyways, it's actually kind of comfortable. My dog's freaking out. It's like staring at me. What's up, dog? Anyways, let's continue. By the way, look at, there's some like signatures on it. Yeah. Okay, so here we go. So this piece right here is half the distance of 40, so we're going to get 20. This looks like the job for Pythagorean's theorem. So all we have to do is go ahead and do h squared plus 20 squared equals 25 squared. And let's go ahead and square it. Oh, I know this. This is easy. Come on, that's 400. That's 625. Come on. What a joke. Okay, subtract that. We get h squared equals, what is that, 225? Are you kidding me? Look how beautiful these numbers are. It's like they were chosen. They were chosen for me. All right. Still sick. Went to the doctor, though. Even better. Okay, so we got 15 there for our height. So now we know the height. I don't care about the slant height. What is that noise? That's the slant. I want true height. True height here, people. So true height here is 15. Let's go ahead and find the area of the base figure. It is a square. So we're just going to do 40 times 40, just like we did in our last problem. So we get 40 squared, which I believe, what is that, 1600? Just double checking, and it is perfect. All right, and then volume equals 1/3, and we get, what is this? Big B times H. Plugging it in, 1600 times the height of 15, and we take 1/3 of it. My 3's look horrible on this, I'm sorry. So times 15 divides by 3, and our volume ends up being 8,000 feet. And those are cubic feet, because we're dealing with volume. Okay? So let's continue on and clear this, and let's look at, let's skip the volume of a cone, because that's easy. Let's do something difficult here. Let's do an oblique cone. Sounds fancy, doesn't it? It's not fancy. An oblique cone means that this point right here is not directly centered over it like on the ice cream cone. So it's like kind of like shifted over, so to speak. And we don't want the side piece, we want the true height. And here they gave us the true height, so we're chilling. So our volume is 1/3 pi r squared times height. Well, 30 is our diameter, our radius is going to be half of that, so it's 15. And so we get pi 15. I'm gonna cough there, that's good. The more I talk, the more I cough, I've noticed. There we go. And 1/3. So what we have to do is calculate, and here we are, 15 squared times 25, divide by 3, and notice I did all the numbers and I left pi out because I'm going to leave pi in as our final answer, and we're going to say in terms of pi. Alright, cool, so this is in feet, cubic feet. But then it also wants me to give the round to the nearest cubic foot. So I gotta multiply that times pi. And I don't remember where the pi button is on here. I will find it. You will never evade me. And here we go. And to the nearest foot we get 5,800 and let's go, we'll call that 90 cubic feet because I said to the nearest cubic foot. So either one of those we have in terms of pi and not in terms of pi. Alright, so that's it. Let's get some good practice and quack, 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 Mr. Ducksworth.